so now we want to talk about three different types of nebulas. So all three of these are going to be big gas clouds. So the first kind of gas cloud is going to have a lot of dust in it. And so it's going to have so much dust that you're not going to be able to see the stars that are behind it. So if your eye is over here, and so here's the nebula, and then here's some stars that are behind it. So the light from those stars are going to be blocked by all of this dust in here. So it's just going to look very, very dark. So that's going to be a dark nebula, and then it's because of the absorption of the light from these stars. Okay, the second one is going to be a reflection nebula, and notice that this is also going to be caused by dust, the scattering of the light caused by the dust. And so this is going to be very similar to why you have blue skies on Earth. So in the case of Earth, you have the sun is right here. Now the sun is going to give off all different kinds of light. So it's going to give off the Roy G. Biv. It's going to give off red and orange and yellow and green and blue and violet. So all the colors of the rainbow are going to be coming from the sun. Okay, but there are going to be gas molecules in our atmosphere, such as oxygen and nitrogen, that are going to absorb some of that light and then re-emit it. And so the preferential color that the oxygen and the nitrogen are going to absorb is going to be the color blue. So that blue light is going to be re-emitted by these molecules, by these atoms, in all different directions. So let's say that some of this blue light goes over here, and then it hits another oxygen atom over here and is absorbed and then is re-emitted. But this time, let's say that the blue is re-emitted in this direction, and you just happen to be down here, so that when you look off to the side, you see the color blue. When you look over here, you see the color blue. So you see the color blue everywhere except if you're looking at the sun. Now don't look at the sun, but the sun is going to be transmitting all of those other colors except the color blue, because the color blue got scattered by the oxygen and nitrogen atoms in the atmosphere. So this time it's not going to be oxygen and nitrogen that's doing it, it's going to be dust. So in a reflection nebula, what's going to happen is that light from these stars back here are going to be interacting with the dust, and it's going to be preferentially scattering the blue light, and then the other colors are going to head to your eye. So it's very similar to why we see blue skies here on Earth. Then the last one is going to be the emission nebula, and this is going to be caused by gas. So the dark nebula and the reflection nebula were caused by dust. This one is going to be caused by the gas that's in the nebula. And just like a emission spectrum, those gases are going to be hit by the light. And then we talked about the apartment building, so that each of the atoms in the nebula can be thought of as being a little apartment building where the electrons live. And then when they get hit by light, then the electrons, they jump up energy levels, and then when they come back down, they emit light of a certain frequency. And so that was called the emission spectrum. And so that is what a emission nebula is going to be. It's going to be these gases that are going to be lit up. And so you'll see that it's the color red. Okay, let's take a break. When we come back, we're going to talk about what are the forces on a nebula.